Hello there, fellow travellers of the cosmic unknown, and welcome to the Weary Researcher. I'm so glad you found your way here tonight. Whether you're settling in after a long day, curled up somewhere comfortable, or simply letting your mind wander through the vast possibilities that lie beyond our earthly boundaries. Tonight, we're embarking on perhaps one of the most sobering journeys through theoretical physics, one that might just change how you think about humanity's greatest dream of reaching the stars. We're going to explore something that science fiction has made seem not just possible, but inevitable: the idea of travelling faster than light, of zipping between star systems like cosmic highways, of making the universe our neighbourhood rather than an impossibly vast prison of distance and time. But here's the thing that keeps physicists awake at night: the dark secret hidden beneath all those gleaming starships and warp drives. What if faster than light travel isn't just difficult or impractical? What if it's actually one of the most dangerous things we could ever attempt? What if the very act of breaking that cosmic speed limit would unleash forces so destructive, so fundamentally reality-breaking, that they could threaten not just the travellers, but entire civilizations, solar systems, and possibly the fabric of existence itself? Before we dive into this cosmic horror story written in the language of mathematics and physics, I'd love to know where in the world you're watching from and what time it is in your corner of the universe. There's something beautifully ironic about exploring the dangers of faster than light travel while we're all separated by the very distances that make such travel seem so appealing in the first place. If you find these explorations into the darker corners of theoretical physics both fascinating and unsettling, I'd be ever so grateful if you gave this video a like and perhaps subscribed. It helps more curious minds discover these deep dives into the mysteries that keep scientists both excited and terrified about what might be possible in our universe. Now, I should warn you that tonight's journey might be just disturbing enough to keep you thinking long after you intended to drift off to sleep. But if it does, at least you'll have gained a profound appreciation for why the universe might have imposed that cosmic speed limit for very good reasons indeed. Reasons that go far beyond simple physics and venture into the realm of cosmic safety mechanisms that prevent reality itself from unravelling. So settle in, take a deep breath, and prepare to discover why faster than light travel might be the universe's ultimate forbidden fruit, a tantalising possibility that comes with a price so catastrophic that even attempting it could spell doom for everything we hold dear. Picture this scenario for a moment. It's the year 2157, and humanity has finally cracked the code. After decades of theoretical breakthroughs and engineering marvels, we've built our first faster-than-light spacecraft. The Prometheus sits gleaming in Earth orbit, a triumph of human ingenuity and determination. Its experimental Alcubierre drive hums with exotic matter, ready to compress space in front of the ship and expand it behind, creating a bubble of warped space-time that can surf through the cosmos faster than photons themselves. The crew is eager, the mission is clear, and the destination is Alpha Centauri, our nearest stellar neighbour. Just over 4 light years away, it represents humanity's first step into the galactic community. With conventional propulsion, the journey would take tens of thousands of years, but with faster-than-light travel, they could be there and back in time for dinner. The countdown begins. The drive engages, and in that moment, the crew of the Prometheus doesn't just break the speed of light. They break something far more fundamental. They break causality itself, the basic principle that cause must precede effect, that events must unfold in a logical sequence, that the universe must make sense. But that's just the beginning of their problems, because as we're about to discover together, faster-than-light travel doesn't just bend the rules of physics, it shatters them so completely that the very attempt could unleash a cascade of destruction that makes nuclear weapons look like firecrackers. The first and most fundamental danger of faster-than-light travel lies in something that Einstein discovered over a century ago. Something so basic to the structure of reality that violating it doesn't just break physics, it breaks logic itself. According to special relativity, the speed of light isn't just a speed limit for matter and energy, it's the speed limit for causality, for the fundamental relationship between cause and effect that makes reality coherent and sensible. When we talk about the dangers of FTL travel, we're not talking about engineering challenges or technological hurdles. We're talking about something far more profound and terrifying: the complete breakdown of the logical structure of existence. Imagine a universe where effects can precede their causes, where you could receive a phone call before it was made, where you could die before you were born. This isn't science fiction speculation. This is the inevitable mathematical consequence of faster-than-light travel according to our best understanding of how space and time actually work. The mathematics of relativity show us something deeply unsettling about FTL travel. When examined through different reference frames, faster-than-light journeys inevitably create situations where events occur in different orders for different observers. What looks like a simple trip from Earth to Alpha Centauri to one observer becomes a journey backward through time to another. The faster you go beyond light speed, the further back in time you arrive, until you're literally arriving before you left. This creates what physicists call the grandfather paradox on a cosmic scale. Not just the possibility of going back and preventing your own birth, but the possibility of creating logical contradictions so fundamental that reality itself becomes self-contradictory. A universe where faster-than-light travel is possible would be a universe where the concept of before and after becomes meaningless, where cause and effect become arbitrary, where the very notion of a coherent timeline dissolves into chaos. But the causality violations are just the beginning. The energy requirements for faster-than-light travel reveal another layer of cosmic horror. According to Einstein's equations, accelerating any object with mass to the speed of light would require infinite energy. Not just a lot of energy, not just more energy than we currently have access to, but literally infinite energy. Every joule in the universe wouldn't be enough. Every star, every galaxy, every particle of matter and energy that exists wouldn't provide sufficient power to push even a single atom to light speed, let alone beyond it. This isn't a technological limitation that we might overcome with better engineering or more advanced power sources. It's a fundamental barrier written into the structure of space-time itself. The universe appears to have built-in protection against faster-than-light travel, as if the cosmos itself recognizes how dangerous such speeds would be. Yet theoretical physicists have proposed ways around this barrier. Exotic solutions involving negative energy and warped space-time that might make FTL travel possible without directly violating relativity. These solutions, like the famous Alcubierre drive, don't accelerate the spacecraft faster than light through space. Instead, they manipulate space itself, contracting it in front of the ship and expanding it behind, creating a bubble that can move faster than light, while the ship inside remains stationary relative to its local space-time. It's an elegant solution that seems to sidestep the energy problem entirely, but as we dig deeper into the physics of such systems, we discover that they come with their own catalogue of catastrophic dangers. The exotic matter required to create these space-time distortions would need to have negative energy density, a form of matter so strange and unstable that its very existence could threaten the structure of reality itself. Negative energy isn't just unusual, it's actively destructive to the fabric of space-time. Creating regions of negative energy density could potentially tear holes in reality itself, creating uncontrollable quantum effects that cascade far beyond the immediate vicinity of the FTL drive. We're talking about the possibility of literally ripping apart the quantum vacuum, the underlying foundation of all matter and energy in the universe. The quantities of exotic matter required are staggering beyond comprehension. Even the most optimized theoretical designs for Alcubierre drives require energy equivalent to converting the mass of entire planets into pure negative energy. We're not talking about the energy output of stars or galaxies. We're talking about fundamentally altering the properties of matter on a planetary scale, creating substances that may be inherently unstable and dangerous to everything around them. But let's imagine for a moment that we somehow solve the exotic matter problem, that we develop the technology to create and control negative energy densities without destroying ourselves in the process. Even then, the dangers of FTL travel are far from over, because the act of travelling faster than light creates its own unique forms of destruction that turn every FTL spacecraft into a potential weapon of unimaginable power. When a ship travels faster than light using something like an Alcubierre drive, it accumulates particles and radiation from the space it passes through. These particles get trapped in the warped space-time bubble surrounding the ship, compressed and accelerated to incredible energies. During the journey, this might seem like a minor side effect, but when the ship decelerates and the warp bubble collapses, all of that accumulated matter and energy gets released in a single, devastating burst. This isn't just dangerous for the ship itself, it's catastrophic for anything at the destination. The deceleration from FTL speeds would release a focused beam of particles and radiation so energetic that it could sterilize entire planets, vaporize space stations, or even damage stars themselves. Every FTL ship becomes a relativistic weapon that destroys its destination simply by arriving there. The physics of this destruction are as elegant as they are terrifying. The particles accumulated during FTL travel become blue-shifted to extreme energies when released, creating radiation bursts that dwarf the most powerful gamma-ray bursts we've observed in nature. A single FTL ship arriving at Earth could release more energy than our Sun produces in years, all focused into a narrow beam pointed directly at whatever lies ahead of the ship's trajectory. This means that FTL travel doesn't just threaten the travelers, it threatens every destination they might visit, every inhabited world, every space station, every sign of life or civilization becomes a potential casualty of the very technology meant to connect them to the wider universe. The dream of galactic civilization, enabled by FTL travel, becomes a nightmare of inadvertent genocide, where each ship carries the potential to destroy the very worlds it seeks to explore. And these dangers compound when we consider the visual and navigational hazards of FTL travel. A ship moving faster than light literally outruns its own sensors. Light from ahead of the ship can never catch up to provide visual information about what lies in the ship's path. Radar, LiDAR, and every other form of electromagnetic detection becomes useless. The ship flies blind through space, unable to see where it's going or receive any advance warning of obstacles in its path. From the perspective of outside observers, FTL ships would appear and disappear like ghosts. They would be completely invisible until the moment they arrive, at which point they would suddenly materialize, often with catastrophic results. The first warning that an FTL ship was approaching would be the devastating radiation burst of its arrival. There would be no time to prepare, no opportunity to communicate, no chance to avoid whatever destruction the ship's deceleration might bring. For the crew inside an FTL ship, the experience would be equally disorienting and dangerous. The extreme distortion of space-time around the ship would create gravitational effects that could tear the human body apart. The difference in gravitational acceleration between a person's head and feet could become so extreme that it literally stretches them beyond the breaking point. Astronauts talk about the dangers of tidal forces near black holes, but FTL drives might create similar or even worse conditions right inside the spacecraft itself. The time dilation effects near FTL speeds would create additional biological hazards. Even approaching light speed causes time to dilate dramatically, and the quantum effects involved in FTL travel could create temporal distortions so severe that biological processes begin to break down. The complex chemical reactions that sustain life depend on precise timing, and extreme time dilation could disrupt cellular function at the most fundamental level. But perhaps the most terrifying aspect of FTL travel dangers is that they might not be limited to the immediate vicinity of the ship or its destination. The manipulation of spacetime required for faster-than-light travel could have consequences that ripple out across vast regions of space, potentially affecting entire star systems or even larger structures. The gravitational waves generated by warping spacetime for FTL propulsion could disrupt the delicate orbital mechanics of planetary systems. Worlds that have maintained stable orbits for billions of years could suddenly find themselves spiraling into their stars or being ejected into the cold of interstellar space. The gravitational disturbances could persist long after the FTL ship has departed, leaving devastated regions of space in its wake. These effects might not even be predictable or controllable. The physics of extreme spacetime manipulation are so far beyond our current understanding that we have no way to model or anticipate all the possible consequences. Each FTL journey could be an experiment with reality itself, with outcomes that could range from merely catastrophic to universe-threatening. The quantum mechanical implications add yet another layer of danger. The quantum vacuum, the underlying foundation of all matter and energy, is far from empty. It seethes with virtual particles and quantum fluctuations that normally cancel each other out in precise balance. But the extreme conditions created by FTL drives could disrupt this balance, potentially triggering runaway quantum effects that cascade beyond all control. We're entering territory where the very concepts of matter and energy, space and time, cause and effect begin to break down, where the comfortable assumptions that allow us to navigate daily life become meaningless, where the universe reveals aspects of itself so alien and dangerous that they challenge our ability to remain sane while contemplating them. And we're only beginning to scratch the surface of why faster-than-light travel might be the most dangerous thing humanity could ever attempt. The rabbit hole of FTL dangers goes deeper still, into realms where physics meets philosophy, where the nature of existence itself comes under threat, and where the simple dream of reaching the stars transforms into a cosmic nightmare that could end not just human civilization, but reality as we know it. As you rest there in the quiet darkness, contemplating these cosmic dangers, remember that we're dealing with forces and phenomena so far beyond human experience that even our best theoretical frameworks can only hint at their true implications. The universe, it seems, has very good reasons for maintaining that cosmic speed limit. Reasons that become more terrifying the deeper we dig into the mathematics of what happens when that limit is broken. The horror story deepens when we examine what faster-than-light travel would do to the fundamental particles that make up reality itself. Deep in the quantum realm, where the normal rules of physics give way to probability and uncertainty, FTL conditions would create instability so profound that they could unravel the very fabric of matter. Consider the theoretical particles called tachyons, hypothetical entities that would naturally travel faster than light. At first glance, they might seem like the perfect solution to our FTL dreams. Particles that are born moving faster than light, that slow down as they gain energy rather than speed up. But the mathematics of tachyons reveals something deeply disturbing about the nature of faster-than-light existence. Tachyons, if they existed, would destabilize the quantum vacuum itself. The vacuum isn't empty space as we might imagine, but a seething ocean of quantum activity, where virtual particles constantly pop into existence and annihilate each other in perfect balance. This delicate dance maintains the stability of all matter and energy in the universe, but tachyons would disrupt this balance, creating runaway instabilities that could cascade through the quantum substrate of reality. The implications are staggering. A single tachyon could theoretically trigger a phase transition that would fundamentally alter the properties of matter throughout the universe. The atoms that make up your body, the stars in the sky, the planets orbiting distant suns, all depend on the current stable configuration of the quantum vacuum. Disturb that stability, and everything we know could simply cease to exist, replaced by forms of matter and energy that operate according to completely different rules. This is why most physicists consider tachyons to be mathematical ghosts, theoretical artifacts that point to problems in our equations rather than real particles waiting to be discovered. The universe seems to have built-in protection against their existence, as if the cosmos itself recognizes how dangerous they would be. But FTL travel might force us to create similar conditions artificially, potentially triggering the very instabilities that natural law appears designed to prevent. The radiation hazards of FTL travel extend far beyond what any science fiction story has dared to imagine. When we manipulate space-time to achieve faster than light speeds, we're not just bending the rules of physics. We're creating conditions similar to those found near black holes, where the boundary between space and time becomes fluid and dangerous. Theoretical calculations suggest that any functioning FTL drive would generate what physicists call Hawking radiation, the same deadly emission that causes black holes to slowly evaporate over cosmic time. But unlike the gentle trickle of radiation from a natural black hole, an FTL drive would concentrate this emission into intense bursts that would be instantly lethal to any biological life. The temperatures involved would be beyond anything we can easily comprehend. We're talking about thermal conditions that would make the core of the Sun seem cool by comparison. The quantum processes near the event horizons created by FTL drives would generate radiation so energetic that it would break apart atomic nuclei, turning any matter it encountered into a plasma of free protons, neutrons, and electrons. But the thermal effects are just the beginning. The exotic particles created by these extreme quantum processes would include forms of radiation that don't exist anywhere else in the natural universe. High-energy gamma rays, exotic mesons, strange quarks, and other particles that exist only in the most violent cosmic events would flood the interior of any FTL spacecraft. No shielding we can imagine would be sufficient to protect the crew from this quantum storm. The biological effects would be immediate and absolute. DNA would be shredded by high-energy particles passing through living cells. Proteins would be denatured by thermal radiation. The complex chemistry that sustains life would be disrupted at the most fundamental level. Death wouldn't come from radiation sickness over days or weeks. It would be instantaneous, as the very molecules that make up living tissue are torn apart by forces that exist nowhere else in the natural world. Even if we somehow solved the radiation problem, perhaps by creating some form of exotic matter shielding that could absorb or deflect these deadly emissions, we would face an even more fundamental challenge. The information paradoxes created by FTL travel could make it impossible to maintain coherent matter or stable memories during the journey. Quantum mechanics tells us that information cannot be destroyed, that the quantum states that define the properties of matter and energy must be preserved, even as they change and evolve. But the extreme conditions created by FTL travel could scramble this information so thoroughly that recovery becomes impossible. Imagine trying to reassemble a jigsaw puzzle after it's been fed through a blender. The pieces might still exist, but their relationships to each other have been so disrupted that the original picture can never be restored. For travellers on an FTL ship, this could mean that their memories, their personalities, even their basic biological functions could become scrambled during the journey. They might arrive at their destination as fundamentally different people, or as collections of matter that no longer retain any coherent structure or function. The quantum information that defines who they are could be so thoroughly mixed that recovery would be impossible. The gravitational effects of FTL systems pose threats that extend far beyond the immediate vicinity of the spacecraft. When we warp spacetime to achieve faster than light travel, we're not just creating a local distortion, we're sending gravitational waves rippling out through the cosmos at the speed of light, carrying energy and momentum that could disrupt the delicate balance of entire stellar systems. Consider what would happen if an FTL ship passed near a planetary system, like our own solar system. The gravitational waves generated by the ship's passage could alter the orbits of planets in ways that wouldn't become apparent for years or decades. A world that has maintained a stable orbit for billions of years could suddenly find its path around its star becoming elliptical, carrying it too close to the stellar surface during part of its orbit and too far away during others. The changes might be subtle at first, barely detectable by the most sensitive instruments, but over time they would compound. Seasons would become more extreme as the planet's distance from its star varied more dramatically. Ocean currents would shift as gravitational tides changed. Weather patterns that have remained stable for geological ages would begin to fluctuate wildly. Eventually, the planet might become uninhabitable, its atmosphere boiling away when it passes too close to its star, or freezing solid when it swings too far away. Entire civilizations could be doomed not by direct attack, but by the subtle gravitational aftershocks of an FTL ship that passed through their system years or decades earlier. The effects wouldn't be limited to planets. Asteroid belts could be destabilized, sending rocky projectiles careening through inner solar systems. Comets could be knocked out of their stable orbits, creating unpredictable hazards for any worlds in their path. Even the stars themselves could be affected, their nuclear fusion processes subtly altered by gravitational waves that change the pressure and density conditions in their cores. But perhaps the most chilling aspect of FTL travel dangers is their potential to create self-reinforcing cascades of destruction. Each use of FTL technology could make subsequent uses more dangerous, creating a positive feedback loop that amplifies the risks with every journey. The exotic matter required for FTL drives doesn't simply disappear after use. The negative energy densities and spacetime distortions linger in the regions where they were created, like cosmic scars that never fully heal. As more FTL ships pass through the same regions of space, these distortions could accumulate and interact in unpredictable ways. Imagine space lanes between star systems that become increasingly unstable with each FTL transit. What begins as a safe corridor for faster-than-light travel could gradually transform into a region where the normal laws of physics no longer apply reliably. Ships might find themselves unable to decelerate properly, trapped in runaway FTL conditions that carry them far beyond their intended destinations. Or worse, the accumulated spacetime distortions could create permanent tears in the fabric of reality, regions where the quantum vacuum becomes unstable and begins to decay into lower energy states. These cosmic wounds could spread outward at the speed of light, converting normal matter and energy into forms that cannot support the complex structures necessary for life. The electromagnetic effects of FTL travel add yet another dimension to the catalogue of dangers. The intense electromagnetic fields generated by manipulating spacetime would create radio interference on a galactic scale, disrupting communications and navigation systems across vast regions of space. But the effects would go far beyond simple interference. The high-energy electromagnetic pulses generated by FTL drives could permanently disable electronic systems on any worlds or space stations they pass near. Imagine the effect of a massive electromagnetic pulse that could reach across multiple star systems, instantly destroying the technological infrastructure that advanced civilizations depend on for their survival. Satellites would fall silent, power grids would collapse, computer systems would be reduced to expensive paperweights. Any civilization that had reached a level of technological sophistication would find itself suddenly thrust back into a pre-electronic age, struggling to survive without the tools and systems they had come to depend on. The biological effects of these electromagnetic pulses would be equally devastating. The human nervous system depends on precise electrical signals to coordinate everything from heartbeat to conscious thought. Intense electromagnetic fields could disrupt these signals, causing seizures, cardiac arrest, or neurological damage that leaves survivors permanently disabled. Even if the immediate effects were survivable, the long-term consequences could be equally dire. The disruption of Earth's magnetic field by passing FTL ships could leave our planet vulnerable to solar radiation and cosmic rays that normally would be deflected away from our atmosphere. The protective bubble that has allowed life to flourish on Earth for billions of years could be stripped away in moments, leaving the surface exposed to sterilizing radiation from space. The quantum entanglement effects of FTL travel open up possibilities for destruction that operate outside our normal understanding of space and time. Quantum entanglement creates instantaneous connections between particles regardless of the distance separating them. But the extreme conditions created by FTL drives could manipulate these quantum connections in ways that spread destruction faster than light itself. Imagine quantum-entangled particles that have been scattered throughout a galaxy over millions of years of cosmic evolution. If FTL travel could somehow manipulate the quantum states of these particles, it might be possible to create coordinated effects across vast regions of space simultaneously. Changes made in one location could instantly affect quantum systems light years away, bypassing the normal limitations imposed by the speed of light. This could create a form of quantum warfare where the manipulation of entangled particles allows for instantaneous attacks across galactic distances. But it could also lead to uncontrolled quantum cascades, where changes in one region trigger unpredictable effects throughout the connected quantum network that spans the cosmos. The implications stretch our understanding of causality to the breaking point. If quantum effects can propagate instantaneously across galactic distances, then the cause and effect relationships that we rely on to make sense of the universe become meaningless. Actions could have consequences that appear before the actions themselves, creating logical paradoxes that make rational thought impossible. As we drift deeper into this catalogue of cosmic horrors, it becomes clear that faster-than-light travel represents more than just a technological challenge or a theoretical curiosity. It represents a fundamental threat to the continued existence of rational, comprehensible reality. Each potential method for achieving FTL speeds comes with its own unique forms of destruction, its own ways of unravelling the carefully balanced systems that allow matter, energy, life, and consciousness to exist in stable forms. The universe, it seems, has imposed the speed of light limit not as an arbitrary restriction, but as a crucial safety mechanism that prevents the kind of runaway destruction that FTL travel would inevitably create. Breaking that cosmic speed limit wouldn't just be dangerous for the travellers, it could be dangerous for existence itself, threatening the fundamental structures that allow anything coherent or meaningful to persist in our cosmos. The gentle darkness around you right now represents a universe in stable equilibrium, where quantum fields maintain their delicate balance, where space-time curves smoothly around massive objects, where cause precedes effect in logical sequence. But faster-than-light travel would shatter that equilibrium, replacing the ordered cosmos we know with something far more chaotic, unpredictable, and hostile to every form of complexity that makes life and consciousness possible. Perhaps our isolation in this vast universe isn't a prison to be escaped, but a protection to be treasured. Perhaps the cosmic speed limit that seems to trap us on our small world is actually the thing that keeps our small world and everything on it safe from forces too terrible to contemplate and too dangerous to unleash. Yet even these catastrophic scenarios pale in comparison to what happens when FTL technology encounters the universe's most extreme environments. Black holes, those cosmic monsters where gravity becomes so intense that not even light can escape, represent regions where the normal structure of spacetime breaks down completely. And when FTL systems interact with these gravitational giants, the results could be apocalyptic beyond imagination. Picture an FTL ship attempting to use a black hole's gravitational field as a slingshot, hoping to gain additional speed or change course. The exotic matter powering the ship's drive would interact with the black hole's event horizon in ways that could create what physicists call a firewall, a barrier of pure energy that incinerates anything attempting to cross it. But unlike the theoretical firewalls that might exist around natural black holes, the interaction between FTL drives and event horizons could create energy densities that dwarf anything found in nature. The quantum field fluctuations near a black hole's event horizon are already among the most violent phenomena in the universe. Add the exotic matter and space-time distortions of an FTL drive to this mix, and you create conditions where the very concepts of matter and energy lose their meaning. The boundary between what exists and what doesn't becomes fluid, creating regions where reality itself becomes unstable and unpredictable. But the true horror lies in what happens when these interactions create new black holes. The energy concentrations required for FTL travel are so enormous that they could collapse under their own gravity, forming artificial black holes that grow by consuming the very exotic matter meant to power the ship. These artificial singularities wouldn't follow the stately evolution of natural black holes. They would be unstable, chaotic entities that could merge with existing black holes or spiral out of control in ways that threaten entire galactic regions. The possibility of runaway black hole formation represents perhaps the ultimate FTL disaster scenario. Once formed, these artificial singularities would be impossible to control or contain. They would consume everything in their path, growing larger and more dangerous with each bit of matter they devour. A single FTL experiment gone wrong could create a black hole that eventually consumes its host star, then the entire solar system, then neighbouring systems, spreading outward in an unstoppable wave of gravitational destruction. Even more terrifying is the possibility that FTL drives could destabilize existing black holes, causing them to collapse or explode in ways that release their accumulated mass energy in single catastrophic events. Imagine the energy equivalent of millions of stars suddenly unleashed in a burst of radiation and exotic particles that sterilizes everything within hundreds of light years. The gamma-ray bursts we observe from distant galaxies, among the most energetic events known to science, could pale in comparison to what a destabilized supermassive black hole might produce. The interaction between FTL technology and the fundamental structure of atoms opens up another avenue for cosmic catastrophe. At the heart of every atom lies a delicate balance of forces that keeps protons and neutrons bound together in stable nuclei. The extreme energy densities and exotic particles generated by FTL drives could disrupt this balance, causing atomic nuclei to decay or transform in ways that make stable matter impossible. This isn't just theoretical speculation. We know from particle accelerator experiments that sufficiently high-energy collisions can create exotic forms of matter that don't exist under normal conditions. Strange quarks, charm quarks, and other ephemeral particles that normally exist for only tiny fractions of a second before decaying into more stable forms. But the energy scales involved in FTL travel could create conditions where these exotic particles become stable, potentially converting normal matter into forms that cannot support the complex chemistry necessary for life. The creation of stable strange matter, sometimes called strangelets, represents one of the most terrifying possibilities in all of physics. These hypothetical particles could convert any ordinary matter they touch into more strange matter, creating a chain reaction that spreads outward at a significant fraction of the speed of light. A single strangelet released by an FTL drive could theoretically convert an entire planet into exotic matter in a matter of hours or days. The probability of such events might be vanishingly small under normal conditions, but the extreme energies involved in FTL travel could make them not just possible, but inevitable. Each use of FTL technology would be like rolling cosmic dice, where even the smallest probability of total annihilation becomes unacceptable when the stakes involve the continued existence of matter as we know it. The electromagnetic implications of FTL travel extend far beyond simple radiation hazards. The manipulation of space-time required for faster-than-light speeds would generate electromagnetic fields of unprecedented intensity, fields so powerful they could alter the fundamental properties of empty space itself. The quantum vacuum, far from being truly empty, is filled with virtual particles that normally exist for such brief moments that they have no measurable effect on the macroscopic world. But intense electromagnetic fields can make these virtual particles real, pulling them out of the quantum foam and into observable existence. The fields generated by FTL drives could be so powerful that they create cascading showers of particles and antiparticles, turning empty space into a seething cauldron of matter and energy. These particle cascades could extend far beyond the immediate vicinity of the FTL ship, creating regions of space where the normal vacuum becomes unstable and begins producing matter spontaneously. The energy required to maintain such fields would be enormous, but once started, the process could become self-sustaining. The newly created particles would generate their own electromagnetic fields, which would create more particles, which would generate stronger fields, in a runaway process that could convert vast regions of space into dense clouds of exotic matter and energy. Entire star systems could find themselves engulfed in these electromagnetic storms, their planets stripped of their atmospheres and their stars disrupted by the intense fields. The biological implications of these electromagnetic effects would be catastrophic for any form of life based on chemistry, as we understand it. The molecular bonds that hold together proteins, DNA, and other complex biological molecules depend on precise electromagnetic interactions between atoms. Fields powerful enough to create matter from vacuum would completely disrupt these delicate bonds, reducing any biological tissue to its component atoms in microseconds. But the effects wouldn't stop at the molecular level. The atoms themselves could be ionized by these intense fields, stripping away their electrons and leaving behind bare nuclei that cannot form the chemical bonds necessary for any form of complex structure. Life, consciousness, even the possibility of organized matter would become impossible in regions affected by these electromagnetic storms. The temporal paradoxes created by FTL travel become even more disturbing when we consider their effects on information and memory. If faster-than-light travel allows for communication with the past, then it becomes possible to send information back to earlier times, potentially creating loops where information has no ultimate source or origin. These closed time-like curves could trap entire regions of space-time in logical contradictions that make coherent existence impossible. Imagine receiving detailed plans for an FTL drive from your future self, building the device, and then sending those same plans back to your past self. Where did the information originally come from? The plans exist because you received them from the future, but they were sent to the future because you built the device from plans you received from the future. The causal loop is complete, but it violates our basic understanding of how information and knowledge are created and transmitted. These information paradoxes could extend beyond individual minds to encompass entire civilizations. Historical records could become self-modifying, changing retroactively as information flows backward through time. The past could become fluid, shifting and changing as each new piece of information sent backward creates alterations that ripple forward through the timeline. Reality itself could become unstable, caught in loops of constant revision where no version of events remains consistent long enough to serve as a foundation for rational thought or planned action. The implications for consciousness are particularly troubling. If your memories can be altered by information sent from the future, then your sense of personal identity becomes meaningless. You might remember events that never happened, or forget experiences that shaped who you are. The continuity of self that allows for learning, growth, and meaningful relationships would be severed, leaving behind entities that exist in a constant state of temporal flux. Even worse, the paradoxes could create situations where conscious minds become trapped in logical contradictions. You might simultaneously remember both making and not making crucial decisions, creating internal conflicts that make rational thought impossible. The human psyche evolved to navigate a world where cause precedes effect and the past remains fixed, would be utterly unprepared for existence in a universe where temporal relationships become arbitrary and contradictory. The quantum mechanical effects of FTL travel could fundamentally alter the nature of measurement and observation, the basic processes by which conscious minds extract information from their environment. Quantum mechanics tells us that the act of observation plays a crucial role in determining which of many possible quantum states becomes real. But the extreme conditions created by FTL drives could disrupt this process, making it impossible for conscious observers to extract coherent information about their surroundings. The uncertainty principle, which limits how precisely we can simultaneously know certain properties of quantum particles, could become meaningless under FTL conditions. If space-time itself becomes unstable, then the concepts of position and momentum that the uncertainty principle governs lose their meaning. Particles might exist in states that violate the fundamental assumptions of quantum mechanics, creating situations where the mathematical frameworks we use to understand reality simply break down. This breakdown wouldn't be limited to esoteric quantum effects. The chemistry of life depends on quantum mechanical processes operating within very specific parameters. Electrons orbit atomic nuclei according to quantum rules that determine how atoms can bond together to form molecules. If FTL conditions disrupt these quantum processes, then the complex chemistry necessary for biological function becomes impossible. Proteins would unfold as their quantum mechanical bonds become unstable. DNA would fragment as the quantum forces holding its double helix structure collapse. Even simpler molecules like water could decompose if the quantum mechanical forces that bind hydrogen and oxygen atoms together are disrupted by the extreme conditions near FTL drives. The psychological effects on any hypothetical survivors of FTL travel would be devastating beyond our ability to comprehend. Imagine trying to maintain sanity while experiencing reality where cause and effect operate in reverse, where your memories constantly change, where the fundamental structure of matter becomes unreliable. The human mind evolved to navigate a predictable world governed by consistent physical laws, would be utterly unprepared for existence in the chaos that FTL travel would create. Post-traumatic stress disorder, depression, and anxiety would be the least of the psychological challenges facing FTL travelers. The complete breakdown of logical causality would make it impossible to form coherent plans or learn from experience. How do you adapt to an environment where the lessons you learn today might become invalid yesterday? How do you maintain relationships when your memories of shared experiences keep changing? The social structures that allow civilizations to function depend on shared understanding of cause and effect, common memories of historical events, and the ability to make plans based on reasonable expectations about how the future will unfold. FTL travel would destroy all of these foundations, leaving behind isolated individuals trapped in subjective realities that bear no consistent relationship to the experiences of others. Language itself could become meaningless in an FTL-affected universe. Communication depends on shared meanings for words and concepts, but if the fundamental nature of reality becomes fluid and contradictory, then the concepts we use to describe our experiences would lose their coherence. How do you describe traveling to a destination before you left? How do you explain remembering events that haven't happened yet? The very vocabulary we use to make sense of experience would become inadequate for describing the paradoxical conditions that FTL travel creates. The breakdown of language would isolate conscious beings in private worlds of experience that cannot be shared or communicated to others. Even if multiple individuals somehow survived the physical dangers of FTL travel, they would find themselves unable to compare their experiences or work together to understand what had happened to them. Each survivor would be trapped in a unique version of reality that makes no sense to anyone else. The cultural implications extend far beyond individual psychology to encompass the collapse of everything that makes civilization possible. Art, literature, music, and all other forms of cultural expression depend on shared experiences and common understanding of how reality operates. In a universe where FTL travel has shattered the foundations of logical causality, these shared experiences would become impossible. Religious and philosophical systems that provide meaning and comfort to billions of people would become meaningless in the face of reality, where the basic categories of existence, time, space, cause and effect lose their coherence. The questions that have driven human thought for millennia, questions about purpose, meaning, and the nature of existence, would become literally unanswerable in a universe where existence itself becomes paradoxical and self-contradictory. Scientific knowledge, the accumulated understanding that has allowed our species to gradually comprehend and manipulate our environment, would become useless in a world where the fundamental laws of physics no longer operate consistently. The scientific method depends on the ability to make observations, form hypotheses, and test predictions against reproducible results. But in an FTL-affected universe, the concept of reproducible results would be meaningless because the past could be constantly changing. Even mathematics, the most abstract and seemingly universal of human intellectual achievements, could become unreliable in a universe where logical consistency is violated by temporal paradoxes. If effects can precede causes, then the logical relationships that mathematics describes might no longer hold true. The theorem proved yesterday might become false today if information from tomorrow changes the premises it was based on. The economic systems that organize human society would collapse immediately in the face of FTL-induced temporal paradoxes. How do you maintain property rights when ownership can be retroactively altered by information sent from the future? How do you honor contracts when the parties involved might have their memories of the agreement constantly changing? The entire concept of value, which depends on scarcity and the irreversible nature of exchanges, would become meaningless in a world where transactions could be undone by temporal manipulation. Money itself would become worthless if its value could be altered by information flowing backward through time. Stock markets would cease to function if investors could receive information about future prices. The division of labour that allows complex societies to exist would break down if the skills and knowledge that individuals spend years developing could be instantly obsoleted by information from alternate timelines. As we continue our journey through this catalogue of cosmic horrors, it becomes increasingly clear that faster-than-light travel represents not just a technological challenge, but an existential threat to every aspect of organised existence. The universe we inhabit, with its reliable physical laws, its logical causality, its stable atoms and molecules, its predictable flow of time from past to future, isn't just the backdrop against which human life unfolds. It's the essential foundation that makes any form of complex organisation possible. The speed of light isn't just a barrier to be overcome in our quest to explore the cosmos. It's a cosmic safety mechanism that protects the fundamental structures of reality from the kind of catastrophic breakdown that FTL travel would inevitably trigger. Breaking that barrier wouldn't just be dangerous for the brave souls who attempt the journey, it would threaten the continued existence of logic, causality, and meaning itself. Perhaps the most sobering realization is that these dangers aren't distant theoretical concerns that future generations might need to worry about. They're immediate consequences of the fundamental nature of space-time and causality. The moment anyone, anywhere in the universe, successfully achieves faster than light travel, these catastrophic effects would begin to propagate outward, potentially affecting every other civilization and every other form of conscious life within their eventual reach. The dream of a galactic civilization connected by FTL travel reveals itself to be not just impossible, but actively dangerous to pursue. Each attempt to break the cosmic speed limit would risk not just the lives of the travelers, but the coherent existence of reality itself. The universe, in its apparent wisdom, has given us a cosmos vast enough to inspire wonder and exploration, but has also imposed limits that protect us from the consequences of our own ambitions. In the gentle quiet of this moment, as you contemplate these cosmic dangers from the safety of your small world, remember that our isolation in this vast universe might not be a prison, but a sanctuary. The distances that seem to trap us on Earth might actually be protecting us from forces and phenomena too terrible to comprehend and too dangerous to encounter. The speed of light that prevents us from easily reaching the stars might be the very thing that allows stars, planets, and the life they harbour to continue existing in forms we can recognise and understand. The philosophical implications of these FTL dangers extend into realms that challenge our most basic assumptions about the nature of existence itself. When we contemplate the possibility of faster-than-light travel, we're not just asking whether we can build better rockets or develop more efficient propulsion systems. We're asking whether the universe we inhabit is fundamentally stable, or whether it's balanced on a knife's edge, held together by cosmic speed limits that prevent reality from collapsing into chaos. Consider the profound question of whether consciousness itself could survive in a universe where FTL travel is possible. Our awareness, our sense of self, our ability to form memories and learn from experience all depend on a coherent flow of time from past to future. We build our identities from the accumulation of experiences, each moment building upon the last in a logical sequence that creates the continuous narrative we call our lives. But in a universe where faster-than-light travel breaks the causal relationships that give meaning to experience, consciousness might become impossible in any form we could recognize. How do you maintain a sense of self when your memories are constantly being rewritten by information flowing backward through time? How do you form relationships when your shared experiences with others keep changing retroactively? The very concept of learning becomes meaningless when the lessons you acquire today might be invalidated by events that haven't happened yet. The breakdown wouldn't be gradual or partial, it would be total and immediate. The moment causality becomes negotiable, the moment effects can precede their causes, every assumption that allows conscious minds to navigate reality would become invalid. We wouldn't be dealing with a difficult adjustment period or a steep learning curve. We would be facing the complete dissolution of the logical framework that makes thought itself possible. Perhaps even more disturbing is the realization that these effects might not be limited to the immediate vicinity of FTL travel. The quantum entanglement that connects particles across vast distances could create a web of instantaneous cause and effect relationships that spans the entire universe. A single FTL event in one corner of the galaxy could potentially trigger causality violations that ripple outward through the quantum substrate of reality, affecting distant worlds that have never heard of faster-than-light travel. This quantum interconnectedness suggests that the universe might be far more fragile than we typically imagine. We think of space as mostly empty, of distant galaxies as isolated and independent, of cosmic events as having only local effects. But if quantum entanglement creates hidden connections between distant regions, then the stability of reality everywhere might depend on no one, anywhere, ever attempting to travel faster than light. The implications for the search for extraterrestrial intelligence become deeply unsettling when viewed through this lens. We've often wondered why we haven't detected signs of advanced alien civilizations, why the universe seems so quiet despite containing billions of potentially habitable worlds. The Fermi paradox asks where everybody is, why we don't see evidence of the galactic empires and star-spanning civilizations that should theoretically be possible given the age and size of the universe. Perhaps the answer lies in the dangers of FTL travel. Perhaps every civilization that reaches a sufficient level of technological sophistication eventually attempts to break the cosmic speed limit. And perhaps every such attempt results in the kind of catastrophic breakdown of causality and logic that makes continued existence impossible. The great filter that prevents the emergence of galactic civilizations might not be nuclear war or environmental collapse, or any of the other dangers we typically worry about. It might be the temptation to travel faster than light. This would explain the eerie silence of the cosmos, the absence of the radio signals, and megastructures that we might expect from advanced technological societies. Not because they destroyed themselves through conventional means, but because they discovered FTL travel, and in doing so, unraveled the very fabric of reality that allows technological civilization to exist. The universe might be littered with the quantum remnants of civilizations that push too hard against the cosmic speed limit, leaving behind only chaos where once there were worlds full of conscious beings asking questions about their place in the cosmos. The energy economics of FTL travel reveal another layer of cosmic horror that goes beyond simple engineering challenges. We've already discussed how accelerating any object with mass to light speed would require infinite energy, but the implications of this energy requirement extend far beyond the immediate, practical problems of spacecraft propulsion. If infinite energy is required to reach light speed, then any technology that claims to achieve faster than light travel must be drawing that energy from somewhere. The exotic matter solutions like Alcubierre drives don't eliminate the energy requirement. They simply hide it in the negative energy densities needed to create spacetime distortions. But where does this negative energy come from, and what are the consequences of extracting it from the quantum vacuum? The quantum vacuum, despite its name, is not empty. It contains what physicists call zero-point energy, the minimum energy that quantum fields possess, even in their lowest possible state. This energy is normally unextractable, locked away in quantum fluctuations that average out to zero over time. But the creation of negative energy densities required for FTL travel would necessarily involve manipulating these quantum fluctuations in ways that could destabilize the entire foundation of matter and energy. Imagine if the process of creating exotic matter for FTL drives began to spread beyond the immediate region where it was generated. If the techniques used to create negative energy densities could somehow propagate through the quantum substrate, they could potentially convert vast regions of space into zones where normal matter cannot exist. The technology meant to connect distant worlds could instead create expanding bubbles of altered physics that consume everything in their path. The self-reinforcing nature of these effects makes them particularly terrifying. Each use of FTL technology could make subsequent uses more dangerous, as the accumulated distortions in spacetime create increasingly unstable conditions. What begins as a carefully controlled manipulation of exotic matter could spiral into a runaway process that transforms entire galactic regions into zones where the normal laws of physics no longer apply. But perhaps the most chilling aspect of FTL energy requirements is their potential to trigger what physicists call false vacuum decay. Our current understanding suggests that the universe might exist in what's called a false vacuum state, a condition that appears stable but is actually just a local minimum in the energy landscape of quantum fields. Like a ball balanced on a hill that appears flat but is actually curved, our universe might be sitting in a seemingly stable configuration that could be knocked into a lower energy state by sufficient disturbance. The energy manipulations required for FTL travel could provide exactly the kind of disturbance needed to trigger this transition. If the universe began to decay from its current false vacuum state to a true vacuum with lower energy, the effects would propagate outward at the speed of light, converting everything in their path into forms of matter and energy that operate according to different physical laws. Stars would cease to shine, planets would dissolve, and every form of complex structure would become impossible. This wouldn't be a gradual decline or a partial transformation. It would be the complete replacement of our familiar universe with something utterly alien and hostile to every form of organization and complexity that we recognize. The expanding bubble of true vacuum would be invisible until it arrived, traveling at light speed with no advance warning. Everything inside the bubble would cease to exist in any meaningful sense, replaced by quantum fields in their lowest possible energy state. The biological implications of FTL travel extend far beyond the radiation hazards and gravitational effects we've already discussed. The fundamental chemistry of life depends on precise relationships between different types of atoms and molecules. Relationships that have evolved over billions of years in a universe with stable physical constants and predictable cause and effect relationships. The extreme conditions created by FTL drives could alter the fundamental properties of matter in ways that make biological chemistry impossible. The electromagnetic forces that hold molecules together, the quantum mechanical effects that allow enzymes to catalyze biochemical reactions, the precise energy levels that determine how proteins fold into their functional shapes, all of these could be disrupted by the exotic fields and particles generated by faster-than-light propulsion systems. But the effects wouldn't be limited to direct exposure to FTL drives. The space-time distortions created by these systems could propagate outward as gravitational waves, carrying with them alterations to the fundamental constants that govern chemistry and physics. Worlds that have never seen an FTL ship could find their biospheres slowly degrading as the basic chemical processes that sustain life begin to operate according to slightly different rules. The changes might be subtle at first, barely detectable even with sophisticated instruments. Enzyme reactions might become slightly less efficient. Protein synthesis might become marginally less accurate. DNA replication might develop a slightly higher error rate. But over time, these small changes would compound, leading to the gradual breakdown of the complex biochemical networks that maintain living systems. Eventually, life as we know it would become impossible, not because of catastrophic destruction, but because of the slow erosion of the chemical foundations that make biological processes possible. Organisms might find themselves unable to repair cellular damage, unable to produce the proteins necessary for basic functions, unable to maintain the delicate chemical balances that keep them alive. The psychological and social effects of living in a universe where FTL travel is possible would be devastating even for those who never travel faster than light themselves. The mere knowledge that causality could be violated, that the past could be changed, that effects could precede their causes, would undermine the basic mental frameworks that allow human beings to function as rational creatures. How do you make plans for the future when the future might retroactively alter the past? How do you take responsibility for your actions when those actions might be undone by information sent backward through time? How do you form emotional attachments to other people when your shared memories might be constantly changing due to temporal paradoxes occurring in distant parts of the galaxy? The legal and ethical systems that govern human society would become meaningless in the face of causality violations. The concept of justice depends on the idea that actions have consequences, that people can be held accountable for their choices. But if effects can precede causes, if the timeline itself becomes fluid and changeable, then the very notion of moral responsibility breaks down. Criminal justice systems would collapse when defendants could claim that their crimes were the result of information they received from the future, or that their victims were somehow responsible for their own deaths by sending warnings backward through time. Contract law would become impossible when the terms of agreements could be retroactively altered by temporal manipulation. Property rights would be meaningless when ownership could be changed by information flowing backward from future timelines. Even basic human relationships would become strained under the weight of temporal uncertainty. How do you trust someone when their promises might be invalidated by causality violations? How do you love someone when your memories of your time together might be constantly changing? How do you raise children when the lessons you teach them today might become invalid due to information they receive from their own future selves? The cumulative effect would be the dissolution of human society as we know it, not through war or natural disaster or technological collapse, but through the gradual erosion of the shared assumptions and common experiences that allow groups of people to function together as communities. Each individual would become trapped in their own subjective reality, unable to meaningfully communicate or cooperate with others whose experiences of the same events might be completely different due to temporal paradoxes. The implications for human knowledge and scientific understanding would be equally catastrophic. Science depends on the ability to make reproducible observations, to test hypotheses against consistent natural phenomena, to build understanding through the accumulation of evidence over time. But in a universe where FTL travel makes causality negotiable, the concept of reproducible results would become meaningless. How do you conduct experiments when the outcomes might be influenced by information sent backward from future trials? How do you trust your data when past observations might be retroactively altered by temporal manipulations? How do you build theories when the fundamental relationships between cause and effect become arbitrary and changeable? The scientific method itself would become impossible to apply consistently. The peer review process would break down when different researchers might have different memories of the same experiments. The accumulation of knowledge would stop when each new discovery could potentially invalidate everything that came before by changing the conditions under which previous observations were made. Even mathematics, the most abstract and seemingly universal form of human knowledge, could become unreliable in a universe where logical consistency is violated by temporal paradoxes. If effects can precede causes, then the logical relationships that mathematics describes might no longer hold true. The theorems proved yesterday might become false today if information from tomorrow changes the axioms they were based on. The concept of education would become meaningless when the knowledge passed from one generation to the next could be constantly changing due to temporal influences. How do you teach children about history when historical events might be retroactively altered? How do you prepare them for the future when the future might send information backward that changes the present they're growing up in? Cultural traditions, the practices and beliefs that connect us to our ancestors and provide continuity across generations, would lose all meaning in a universe where the past is mutable. The stories we tell about our origins, the values we inherit from previous generations, the hard-won wisdom accumulated over centuries of human experience, all of this could be swept away by temporal paradoxes that rewrite history itself. The existential implications reach even deeper than the collapse of human society and knowledge. In a universe where FTL travel is possible, the very concept of existence becomes problematic. What does it mean to exist if your existence can be retroactively prevented by information sent from the future? What does it mean to be real if your reality can be altered by temporal manipulations occurring in distant parts of the galaxy? The philosophical questions that have puzzled human thinkers for millennia, questions about the nature of consciousness, the meaning of life, the reality of free will, would become not just unanswerable, but literally meaningless in a universe where the basic categories of existence lose their coherence. The frameworks we use to make sense of experience would become inadequate for describing a reality where logical consistency is constantly violated. Even the simple act of remembering would become fraught with uncertainty. Are your memories real, or are they artifacts of temporal manipulations that have altered your past? Did the events you remember actually happen, or are they false memories created by information flowing backward through time? The continuity of personal identity that allows you to think of yourself as the same person who went to sleep last night would become questionable when your past could be constantly changing. The implications extend beyond individual consciousness to encompass the nature of truth itself. In our current universe, we assume that statements about the past are either true or false, that events either happened or they didn't, that there is an objective reality that exists independently of our observations of it. But in a universe where FTL travel makes the past mutable, these assumptions would become invalid. Truth would become relative not just to different observers, as Einstein showed us, but to different moments in time. A statement that is true today might become false tomorrow, not because our understanding has changed, but because the events the statement describes have been retroactively altered by temporal manipulation. The very concept of objective reality would dissolve into a chaos of competing subjective experiences, each equally valid and equally meaningless. Perhaps most disturbing of all is the realization that these effects might already be occurring in subtle ways that we haven't detected. If some advanced civilization elsewhere in the universe has already developed FTL travel, the causality violations they create could be affecting our reality right now, altering our past in ways too subtle for us to notice. The universe we think we inhabit might already be partially corrupted by temporal paradoxes, our memories and experiences constantly shifting in response to FTL activities occurring in distant galaxies. The history we think we know, the scientific laws we believe we've discovered, the cultural traditions we imagine we've inherited from our ancestors. All of this might be nothing more than the current snapshot of a reality in constant flux, changing in response to temporal manipulations we're powerless to detect or prevent. We might be living in a universe that's already partially broken, held together only by our ignorance of the chaos that surrounds us. This possibility transforms the entire question of FTL travel from a technological challenge into an existential crisis. It's not just about whether we can build ships that travel faster than light. It's about whether we want to live in a universe where such travel is possible, with all the catastrophic consequences that would inevitably follow. The price of breaking the cosmic speed limit might be nothing less than the coherent existence of reality itself. As you rest there in the quiet darkness, surrounded by the gentle stability of a universe where cause precedes effect, where the past remains fixed, where the laws of physics operate consistently from moment to moment, perhaps you can appreciate the profound gift of living in a cosmos that seems designed to protect us from our own ambitions. The speed of light that appears to trap us in our small corner of the galaxy might actually be the thing that allows galaxies, stars, planets, and conscious beings to exist in form stable enough to contemplate their own existence. The distances that separate us from other worlds, the cosmic isolation that sometimes seems so lonely and limiting, might be the very thing that keeps the universe safe from the kind of reality-breaking catastrophes that faster-than-light travel would inevitably unleash. In our quest to reach the stars, we might discover that the greatest wisdom lies not in overcoming the barriers that contain us, but in understanding why those barriers exist in the first place. The universe, in its apparent infinite wisdom, has given us a cosmos vast enough to inspire wonder and curiosity, but has also imposed limits that protect the fundamental structures of existence from the consequences of unlimited ambition. Perhaps the most profound discovery we could make is not how to travel faster than light, but why we should be grateful that such travel appears to be impossible. The gentle rhythm of your breathing, the steady beat of your heart, the quiet flow of thoughts through your mind, all of these simple biological processes depend on a universe where chemistry works reliably, where time flows consistently from past to future, where the quantum foundations of matter remain stable and predictable. The FTL technologies that seem so appealing in science fiction would threaten all of these basic requirements for life and consciousness. In learning to appreciate the cosmic speed limit not as a barrier to be overcome, but as a protection to be treasured, we might find a deeper form of cosmic wisdom. The recognition that some dreams are too dangerous to pursue, that some technologies are too destructive to develop, that some barriers exist not to limit us, but to preserve the very possibility of meaningful existence. The universe may have denied us easy access to the stars, but it has given us something far more precious, a stable reality where consciousness can emerge, flourish, and contemplate the deepest mysteries of existence. Perhaps that gift is worth more than all the distant worlds we might have visited, more valuable than all the cosmic civilizations we might have joined. In the end, the greatest journey might not be outward to the stars, but inward to a deeper understanding of the remarkable universe we already inhabit. A cosmos so finely balanced, so carefully structured, so perfectly designed to support the emergence of conscious beings capable of wondering about their place in the infinite expanse of space and time. The quantum field effects of faster-than-light travel reveal perhaps the most insidious danger of all, one that operates at scales so fundamental that we barely have the vocabulary to describe it. Deep beneath the familiar world of atoms and molecules, beneath even the exotic realm of subatomic particles, lies the quantum vacuum itself. This isn't the empty space that our intuitions suggest, but rather a seething ocean of virtual particles that constantly pop into existence and annihilate each other in perfect, delicate balance. This quantum dance maintains the stability of everything we consider real. The electrons that orbit atomic nuclei, the photons that carry light across the cosmos, the fundamental forces that hold matter together, all depend on the precise choreography of virtual particles in the quantum vacuum. It's like a cosmic symphony where every instrument must play its part exactly right, or the entire performance collapses into chaos. But the energy densities required for FTL travel would be like detonating nuclear weapons in the middle of that delicate orchestra. The exotic matter needed to warp space-time doesn't just bend the rules of physics, it could fundamentally alter the quantum vacuum itself, changing the underlying foundation upon which all matter and energy depend for their existence. Consider what happens when you disturb the quantum foam at these extreme energy scales. The virtual particles that normally exist for mere fractions of a second before disappearing could become real, permanent additions to our universe. But these wouldn't be the familiar particles we know from everyday experience. They would be exotic entities that don't exist anywhere in nature, particles with properties so strange that they could make normal matter unstable simply by being nearby. The creation of these exotic particles wouldn't be limited to the immediate vicinity of an FTL drive. Once formed, they could interact with the quantum vacuum in ways that create cascading effects, like dominoes falling in patterns that spread outward at incredible speeds. Each exotic particle could destabilize the virtual particles around it, causing them to become real, which would destabilize more virtual particles, creating an ever-expanding wave of quantum chaos. This quantum cascade wouldn't just affect empty space, it would fundamentally alter the properties of atoms themselves. The electron orbitals that determine how atoms bond together to form molecules depend on precise quantum mechanical relationships. If the underlying quantum vacuum changes, these relationships could shift in ways that make familiar chemistry impossible. Imagine waking up in a world where water molecules can no longer maintain their stable configuration, where the proteins in your body begin to unfold because the quantum forces that maintain their structure have subtly changed. The transformation wouldn't be dramatic or sudden. It would be a gradual dissolution of the chemical foundations that make life possible, spreading outward from wherever FTL technology had been used, like an invisible plague that attacks the very concept of stable matter. The electromagnetic implications of these quantum effects extend far beyond what we've already discussed. The quantum vacuum itself has electromagnetic properties, and altering its structure could change the fundamental constants that govern how electric and magnetic fields behave. The speed of light itself, that cosmic constant we've been discussing as an absolute limit, could begin to vary from place to place as the quantum substrate that determines its value becomes unstable. Picture regions of space where light travels at different speeds, where the electromagnetic spectrum becomes distorted, where the photons that carry information between distant worlds arrive scrambled and unrecognizable. Radio communications would become unreliable as electromagnetic waves travel different distances depending on the local properties of the altered quantum vacuum. The cosmic background radiation that fills the universe with gentle warmth could be disrupted, creating cold zones where the normal thermal equilibrium of space breaks down. The biological consequences would be catastrophic in ways that go far beyond radiation poisoning or cellular damage. Life as we know it depends not just on stable chemistry, but on the precise quantum mechanical processes that allow biological molecules to function. The quantum tunneling effects that help enzymes catalyze biochemical reactions, the quantum coherence that some researchers believe might be involved in photosynthesis, and even consciousness itself, all of these could be disrupted by changes to the quantum vacuum. Organisms might find their most basic cellular processes beginning to fail as the quantum foundations of biochemistry shift beneath them. DNA replication could become increasingly error-prone as the quantum mechanical forces that guide molecular interactions change their behavior. Protein synthesis might become inefficient or stop altogether as the quantum properties of amino acids drift away from their normal values. The effects wouldn't be limited to individual organisms. Entire ecosystems could begin to collapse as the quantum changes propagate through food webs and environmental systems. Plants might find themselves unable to perform photosynthesis efficiently as the quantum properties of chlorophyll molecules change. Animals could lose their ability to process nutrients as their digestive enzymes stop functioning properly due to altered quantum mechanics. The technological implications are equally terrifying. Every piece of electronic equipment we depend on, from simple calculators to sophisticated computers, relies on the precise quantum mechanical properties of semiconductors. If the quantum vacuum changes, the band gaps that allow transistors to function could shift, making all of our electronic technology suddenly unreliable or completely non-functional. Power grids could fail as the quantum properties of electrical conductors change. Communication systems could break down as the quantum mechanics of electromagnetic radiation are altered. Transportation systems that depend on electronic controls could become dangerous or impossible to operate. An advanced technological civilization could find itself suddenly thrust back into a pre-electronic age, not through war or natural disaster, but through the subtle alteration of quantum mechanical constants. But perhaps the most disturbing aspect of quantum vacuum decay is its potential for creating what physicists call bubble nucleation. If FTL technology creates regions where the quantum vacuum has transitioned to a lower energy state, these regions could expand outward at the speed of light, converting everything in their path to the new vacuum state. It would be like a cosmic infection that spreads through the fabric of space-time itself, replacing our familiar universe with something utterly alien. The boundary of such an expanding bubble would be invisible and undetectable until it arrived. There would be no advance warning, no opportunity to prepare or escape. Everything inside the bubble would be subject to new physical laws, new quantum mechanical relationships, new fundamental constants. Stars might cease to shine as nuclear fusion becomes impossible under the altered physics. Planets might dissolve as the forces that hold their atoms together no longer operate in familiar ways. The expansion would be relentless and unstoppable. Once begun, the process would continue until either the entire universe had been converted to the new vacuum state, or until the expanding bubble encountered some barrier we don't currently understand. Every world, every civilization, every form of conscious life would be swept away in a transformation so complete that even the concept of existence would need to be redefined. The psychological implications of living in a universe where such quantum catastrophes are possible would be overwhelming. How do you maintain hope and optimism when you know that the fundamental structure of reality could be undermined at any moment by FTL experiments happening in distant galaxies? How do you plan for the future when that future could be erased by quantum effects you can neither detect nor prevent? The knowledge that consciousness itself might depend on quantum processes that could be disrupted by FTL technology adds another layer of existential terror. Recent research suggests that some aspects of neural function might involve quantum coherence effects in microtubules within brain cells. If these quantum processes are disrupted by changes to the vacuum state, consciousness itself could begin to break down in ways that would be undetectable to the conscious minds experiencing the breakdown. You might find your thoughts becoming less coherent, your memories more unreliable, your ability to focus and concentrate gradually deteriorating, all without realizing that these changes are symptoms of quantum mechanical disruption affecting the deepest levels of neural function. The very instrument you would use to detect and understand such changes, your own conscious mind, would be compromised by the same processes you're trying to observe. The social and cultural implications extend into realms that challenge our most basic assumptions about human nature and civilization. If consciousness can be altered by quantum mechanical effects, then the shared assumptions and common experiences that allow societies to function could gradually erode as quantum changes propagate through populations of conscious beings. Languages might begin to lose their coherence as the quantum processes involved in memory and communication are subtly altered. Cultural traditions could fade as the quantum basis of long-term memory becomes unreliable. The accumulated wisdom of civilizations could be lost not through catastrophic destruction, but through the gradual degradation of the quantum mechanical processes that allow knowledge to be preserved and transmitted across generations. Educational systems would become increasingly ineffective as students and teachers find their ability to learn and remember compromised by quantum effects they don't understand. Scientific research would grind to a halt as researchers lose the ability to maintain the focused attention and reliable memory necessary for complex investigation. The technological progress that has characterized human civilization for centuries could reverse as the quantum foundations of advanced thinking begin to deteriorate. The economic implications are equally staggering. Markets depend on the rational decision-making abilities of participants, on their capacity to remember past events and plan for future outcomes. If quantum mechanical disruption begins to affect these cognitive abilities, economic systems could collapse not through external shocks or policy failures, but through the gradual erosion of the mental capabilities that make complex economic coordination possible. Financial institutions would find their risk assessment models becoming increasingly unreliable as the quantum effects influencing human decision-making create unpredictable market behaviors. long-term investments would become impossible to evaluate as the cognitive abilities of both investors and analysts deteriorate due to quantum disruption. The complex web of contracts, agreements, and trust relationships that undergird modern economies could unravel as the mental processes necessary to maintain such relationships are compromised at the quantum level. The military and security implications add yet another dimension of horror to this quantum catastrophe scenario. If FTL-induced quantum effects can disrupt consciousness and cognitive function, they could potentially be weaponized in ways that make conventional warfare seem primitive by comparison. Imagine quantum weapons that attack not just physical targets, but the quantum mechanical basis of thought itself. Such weapons wouldn't need to destroy cities or kill populations directly. They could simply alter the quantum vacuum in targeted regions, gradually degrading the cognitive abilities of everyone in those areas until organized resistance becomes impossible. Military command structures would collapse as officers lose the ability to think strategically or remember tactical procedures. Civilian governments would become ineffective as leaders find their decision-making capabilities compromised by quantum effects. The defense against such attacks would be virtually impossible because the weapons would operate at scales far below what conventional detection systems can monitor. By the time the effects became noticeable, the quantum damage would already be done, and the cognitive abilities necessary to mount an effective response would be compromised. The environmental implications of quantum vacuum decay present a form of ecological catastrophe that goes far beyond anything we typically consider when discussing environmental threats. Climate change, pollution, habitat destruction, all of these pale in comparison to the potential for FTL technology to alter the quantum mechanical foundations that make terrestrial life possible. Ecosystems are incredibly complex networks of interactions between countless species, each depending on biochemical processes that operate according to precise quantum mechanical principles. If these principles begin to change due to quantum vacuum decay, the entire web of life could begin to unravel in ways that would be impossible to predict or prevent. Pollinating insects might find their navigation systems disrupted as the quantum properties of the molecules they use to detect flowers are altered. Migrating animals could lose their ability to navigate using quantum effects in their sensory systems. The microscopic organisms that form the base of most food webs could find their metabolic processes becoming inefficient or impossible as the quantum mechanics of cellular biochemistry shifts. The changes might be so subtle initially that they would be attributed to other causes. Declining bee populations, unusual migration patterns, unexplained die-offs of marine organisms, all could be early symptoms of quantum vacuum decay spreading through Earth's biosphere. By the time the true cause was identified, if it ever could be, the damage might be irreversible and unstoppable. The geological implications are equally disturbing. The quantum mechanical forces that hold atomic nuclei together determine the stability of the elements that make up Earth's crust, mantle, and core. If these forces begin to change due to FTL-induced quantum effects, even the solid ground beneath our feet could become unreliable. Radioactive decay rates could shift, affecting both the natural background radiation that life has adapted to and the radiometric dating techniques we use to understand Earth's history. The nuclear processes that power Earth's magnetic field could be disrupted, leaving our planet vulnerable to solar radiation and cosmic rays. The tectonic processes that have shaped our planet's surface for billions of years could become unpredictable as the quantum properties of rock-forming minerals change. Mountain ranges built over millions of years could begin to crumble as the quantum forces holding their constituent atoms together weaken. Ocean basins could shift as the seafloor spreading process that creates new oceanic crust is affected by altered quantum mechanics. The very continents we live on could become unstable as the quantum foundations of geological processes are undermined by FTL technology used elsewhere in the galaxy. The astronomical implications extend these quantum catastrophes to cosmic scales that dwarf even the most ambitious science fiction scenarios. If quantum vacuum decay can propagate through space at light speed, then FTL experiments in any part of the universe could eventually affect every other part. The stable nuclear fusion processes that power stars could be disrupted, causing them to burn out prematurely or explode in ways that differ from normal stellar evolution. Planetary formation processes could be altered as the quantum mechanical forces that allow dust and gas to accrete into solid bodies change their behavior. The cosmic microwave background radiation that provides crucial information about the early universe could be distorted by quantum effects, making it impossible to understand cosmic history or predict cosmic evolution. Entire galaxies could find their spiral structures disrupted as the quantum properties of dark matter, whatever it might be, are altered by propagating quantum vacuum decay. The large-scale structure of the universe itself, the cosmic web of matter and energy that connects galaxy clusters across billions of light-years, could begin to dissolve as its quantum foundations are undermined. The implications for cosmic evolution are particularly chilling. Our universe has spent nearly 14 billion years developing the complex structures we observe today. Stars, planets, galaxies, and ultimately life and consciousness all represent the gradual organization of matter and energy into increasingly sophisticated forms. But quantum vacuum decay triggered by FTL technology could reverse this entire process, reducing the organized complexity of the cosmos to a uniform, lifeless soup of altered quantum fields. The irony is profound and tragic. In our quest to connect with other civilizations, to join a galactic community of conscious beings, we could inadvertently destroy the very possibility of consciousness existing anywhere in the universe. The technology meant to bring us together could ensure that we remain forever alone, not because we're isolated by distance, but because we've eliminated the quantum mechanical foundations that allow complex life to exist. As you drift deeper into contemplation of these quantum horrors, surrounded by the comforting stability of a universe where atomic nuclei maintain their integrity, where the quantum vacuum remains in its familiar state, where the fundamental constants of nature operate reliably from moment to moment, perhaps you can appreciate the profound wisdom embedded in the cosmic speed limit that seems to protect us from these catastrophic possibilities. The universe appears to have been constructed with remarkable foresight, establishing barriers that prevent conscious beings from accidentally destroying the very foundations of existence in their enthusiasm to explore and expand. The speed of light that seems to limit our cosmic ambitions might actually be the thing that preserves the possibility of having cosmic ambitions at all. In the gentle darkness that surrounds you now, as quantum fields fluctuate in their eternal dance of creation and annihilation, as virtual particles wink in and out of existence in perfect balance, as the fundamental forces maintain their precise relationships that allow atoms to exist and life to flourish, you are witnessing the cosmic miracle of stable existence. The universe has given us not just a stage upon which the drama of consciousness can unfold, but a stage that remains reliably solid beneath our feet, unchanging in its essential character, predictable enough to allow for the accumulation of knowledge and the development of wisdom. Perhaps the greatest journey we can undertake is not outward to distant stars, but inward to a deeper appreciation of the quantum mechanical foundations that make any journey possible at all. In understanding why faster than light travel would be so catastrophically dangerous, we gain insight into why the universe we inhabit is so remarkably, improbably, and preciously stable. The quantum vacuum that surrounds you at this very moment, invisible and intangible though it may be, represents one of the most sophisticated and delicate systems ever discovered. more complex than any technology we've developed, more precisely balanced than any equation we've solved, more essential to our existence than any resource we've ever exploited. It is the foundation upon which everything else rests, and FTL travel would threaten to tear that foundation apart. In learning to see the cosmic speed limit not as a barrier to our dreams, but as a guardian of our reality, we might find a form of wisdom that transcends our immediate desires for exploration and expansion. The recognition that some boundaries exist not to confine us, but to preserve the very possibility of being confined at all. That some limits protect not just our safety, but the coherent existence of the universe that makes safety a meaningful concept. The gentle hum of quantum fields in their ground state. The invisible symphony of virtual particles maintaining perfect balance. The quantum mechanical processes that allow your neurons to fire and your thoughts to form. All of these continue their ancient dance in the darkness around you. A dance so fundamental that disrupting it would mean the end, not just of human consciousness, but of the possibility of consciousness emerging anywhere in the cosmos. Perhaps that's worth more than all the distant worlds we might have visited, more valuable than all the alien civilizations we might have met. In preserving the quantum foundations of existence, the universe has given us something infinitely more precious than access to the stars. It has given us the gift of being able to wonder about the stars at all. The technological cascades that would follow any successful FTL breakthrough reveal layers of catastrophe that extend far beyond the immediate physical dangers we've explored. Consider what happens to the delicate web of assumptions that underlies all of our modern technology when the fundamental constants of physics become negotiable through faster than light manipulation. Every computer chip in existence depends on the precise quantum mechanical properties of silicon and other semiconductor materials. The band gaps that allow transistors to switch between conducting and non-conducting states. The electron mobility that determines processing speeds. The thermal properties that govern heat dissipation. All of these rely on quantum mechanical relationships that could be altered by the exotic matter and space-time distortions required for FTL travel. But the failure wouldn't be dramatic or obvious. It would be subtle, insidious, spreading through our technological infrastructure like a slow poison. Computers might begin to make occasional calculation errors as their quantum mechanical foundations shift slightly. The errors would be rare at first, easily dismissed as random hardware failures or software bugs, but they would gradually become more frequent as the quantum substrate continues to drift away from its familiar configuration. Electronic devices that worked perfectly yesterday might become unreliable tomorrow, not because of any visible damage, but because the universe itself has changed around them. Smartphones might drop calls randomly. GPS systems might provide coordinates that drift slowly but inexorably away from actual positions. Medical devices that patients depend on for their survival could begin to malfunction in ways so subtle that the failures would be attributed to aging equipment or manufacturing defects. The cumulative effect would be the gradual erosion of trust in technology itself. When electronic systems become unreliable in unpredictable ways, when the tools we depend on for everything from communication to transportation begin to fail without explanation, society faces a crisis that goes far beyond simple technical problems. The psychological impact of living in a world where technology cannot be trusted would be devastating for a civilization that has become utterly dependent on electronic systems for its basic functioning. But the technological cascade goes deeper than electronic failures. The chemical processes that we use to manufacture everything from medicines to building materials depend on precise molecular interactions governed by quantum mechanical forces. If these forces begin to change due to FTL-induced alterations to the quantum vacuum, the entire industrial base of modern civilization could become unreliable. Pharmaceutical companies might find that drugs which passed years of testing suddenly become ineffective or even dangerous as the quantum properties of their active molecules shift. Chemical plants could discover that reactions which have worked reliably for decades begin to produce unexpected byproducts or fail to achieve the desired outcomes. The plastics that make up countless everyday objects could become brittle or toxic as their molecular structures adapt to altered quantum mechanical conditions. The implications for food production and safety are particularly chilling. The biochemical processes that plants use to create the nutrients we depend on for survival are governed by quantum mechanical effects that could be disrupted by FTL technology. Crops might begin to produce lower levels of essential vitamins and minerals as the quantum basis of plant metabolism shifts. Worse, they could begin to concentrate toxic compounds as altered quantum mechanics disrupts the cellular processes that normally prevent the accumulation of harmful substances. Food preservation techniques that have kept our meals safe for generations could become unreliable as the quantum properties of bacteria and other microorganisms change in response to altered vacuum conditions. Refrigeration might become less effective at preventing spoilage. Pasteurization could fail to eliminate pathogens. Even simple cooking might become insufficient to destroy harmful organisms that have adapted to new quantum mechanical environments. The medical implications extend far beyond pharmaceutical failures. The human body itself is an incredibly complex quantum mechanical system, with cellular processes that depend on precise molecular interactions occurring at quantum scales. The enzymes that digest our food, the proteins that repair cellular damage, the DNA replication processes that allow our cells to divide and replace themselves, all of these could be affected by changes to the fundamental quantum mechanical constants. The effects might manifest initially as increased rates of cancer, autoimmune disorders, and other diseases that result from cellular processes going wrong. Medical professionals might notice that treatments which worked reliably in the past are becoming less effective, that disease patterns are shifting in ways that don't correspond to known environmental or genetic factors. The human immune system evolved over millions of years to operate under specific quantum mechanical conditions could begin to malfunction as those conditions change. Genetic expression could become unreliable as the quantum mechanical forces that control how DNA is transcribed into proteins are altered by FTL-induced changes to the vacuum state. Children might be born with unexpected genetic variations, not because of mutations in their DNA, but because the quantum mechanical machinery that reads and implements genetic instructions is operating under different physical laws than those that prevailed when their parents were conceived. The reproductive implications are particularly disturbing. The quantum mechanical processes involved in meiosis, the cellular division that creates eggs and sperm, are incredibly precise and complex. If these processes are disrupted by changing quantum mechanical constants, fertility rates could plummet as the cellular machinery necessary for reproduction begins to malfunction. Even successful pregnancies could result in offspring with unpredictable developmental abnormalities as the quantum basis of embryonic growth is undermined. The neurological effects could be the most devastating of all. Recent research suggests that consciousness itself might depend on quantum mechanical processes occurring in brain cells. The microtubules that form the structural framework of neurons might use quantum coherence effects to process information in ways that classical physics cannot explain. If FTL technology disrupts these quantum processes, the very nature of human consciousness could begin to change in ways that would be undetectable to the conscious minds experiencing the changes. You might find your thoughts becoming less coherent, your memories more unreliable, your ability to concentrate and focus gradually deteriorating. But because the instrument you use to detect these changes is your own conscious mind, and that mind is being affected by the same quantum disruptions, you might not even realize that your mental capabilities are declining. The degradation could be so gradual and so pervasive that each generation would consider their reduced cognitive abilities to be normal, having no memory of what human consciousness was like before FTL technology began altering the quantum foundations of neural function. The social implications of this cognitive decline would be catastrophic in ways that go far beyond individual suffering. Human civilization depends on the accumulated wisdom and knowledge of previous generations, on the ability of individuals to learn complex skills and pass them on to others, on the capacity for abstract thinking and long-term planning that has allowed us to build the sophisticated societies we inhabit today. If quantum mechanical disruption begins to erode these cognitive abilities, the transmission of knowledge from one generation to the next could become increasingly unreliable. Skills that took centuries to develop might be lost as practitioners find themselves unable to remember the precise techniques required for complex crafts. Scientific knowledge could gradually degrade as researchers lose the ability to maintain the focused attention necessary for rigorous investigation. Educational systems would face challenges that no reform or innovation could overcome. Teachers might find that students are increasingly unable to master material that previous generations learned easily, but the teachers themselves would be affected by the same cognitive decline, so they might not recognize that the problem lies not with their pedagogical methods, but with fundamental changes to the quantum mechanical basis of human learning and memory. The cultural implications extend into realms that touch the very core of what makes us human. Art, literature, music, and all the other forms of creative expression that define human civilization depend on cognitive abilities that could be undermined by quantum mechanical disruption. Artists might find themselves unable to maintain the sustained attention necessary for complex creative projects. Writers could lose the ability to construct coherent narratives or develop sophisticated themes. Musicians might discover that their capacity for the subtle timing and emotional expression that makes music meaningful has been compromised by changes to the quantum processes underlying neural function. The loss wouldn't be dramatic or obvious. It would be a gradual fading of human creative capacity, so slow and pervasive that each generation would simply accept their reduced abilities as normal. The great works of art, literature, and music created in the past would become increasingly incomprehensible to minds that no longer possess the cognitive sophistication necessary to appreciate complex creative expression. Language itself could begin to deteriorate as the quantum mechanical processes involved in memory and communication are disrupted. Vocabularies might shrink as people find themselves unable to remember complex words or abstract concepts. Grammar could become simpler as the cognitive abilities necessary for parsing complex sentences are undermined. The rich, nuanced communication that allows human beings to share complex ideas and emotions could gradually give way to simpler, more concrete forms of expression. The philosophical implications of this cognitive decline are perhaps the most disturbing of all. Human beings have always been distinguished by their capacity for abstract thought, for contemplating questions about meaning, purpose, and the nature of existence itself. If quantum mechanical disruption begins to erode these higher cognitive functions, we could find ourselves gradually losing the very qualities that make us human. The great philosophical questions that have driven human inquiry for millennia, questions about consciousness, free will, the nature of reality, the meaning of life, could become literally unthinkable as the cognitive abilities necessary to contemplate such abstract concepts are undermined by changes to the quantum mechanical foundations of thought. Future generations might look back at the philosophical works of the past with the same incomprehension that we might feel when looking at advanced mathematics, recognizing that something important is being communicated, but lacking the mental capacity to understand what it means. The religious and spiritual implications are equally profound. The capacity for transcendent experience, for feeling connected to something greater than oneself, for experiencing awe and wonder at the mystery of existence, all of these might depend on quantum mechanical processes in the brain that could be disrupted by FTL technology. The spiritual traditions that have provided meaning and comfort to human beings throughout history could become incomprehensible to minds that no longer possess the cognitive sophistication necessary to appreciate their deeper insights. Prayer, meditation, and other spiritual practices might lose their effectiveness as the quantum mechanical processes they depend on are altered by changes to the vacuum state. The sense of meaning and purpose that religious and spiritual traditions provide could gradually fade as the neural mechanisms that generate these experiences are undermined by quantum disruption. The implications for human relationships are equally devastating. Love, friendship, empathy, and all the other emotional connections that bind human beings together depend on complex cognitive and emotional processes that could be affected by quantum mechanical changes. The capacity for deep emotional bonds, for understanding and caring about the experiences of others, for forming the lasting relationships that make human life meaningful, could gradually erode as the quantum foundations of emotional experience are disrupted. Parents might find themselves increasingly unable to form strong bonds with their children, as the quantum mechanical processes involved in emotional attachment are altered. Romantic relationships could become more shallow and transient as the cognitive abilities necessary for deep emotional connection are undermined. Friendships might become more superficial as people lose the capacity for the empathy and understanding that true friendship requires. The cumulative effect would be the gradual dissolution of human society as we know it, not through war or natural disaster, but through the slow erosion of the cognitive and emotional capacities that allow human beings to live together in complex social groups. Communities that have existed for generations could fragment as people lose the ability to maintain the social bonds that hold them together. The democratic institutions that govern modern societies could become ineffective as citizens lose the cognitive abilities necessary to make informed political decisions. The complex negotiations and compromises that democratic governance requires need participants who can understand abstract concepts, remember past events, and plan for future consequences. If these abilities are undermined by quantum mechanical disruption, democratic societies could collapse not through revolution or external conquest, but through the gradual inability of their citizens to participate meaningfully in the political process. Economic systems would face similar challenges as market participants lose the cognitive abilities necessary for complex economic decision-making. The sophisticated financial instruments that modern economies depend on could become incomprehensible to people whose mathematical and abstract reasoning abilities have been compromised. Long-term economic planning would become impossible as the cognitive skills necessary for such planning are eroded by quantum effects. The legal system would face unprecedented challenges as judges, lawyers, and jurors find their cognitive abilities declining due to quantum mechanical disruption. The complex reasoning necessary to interpret laws, evaluate evidence, and make fair judgments could become increasingly difficult as the quantum foundations of human reasoning are altered. Justice itself could become a casualty of FTL technology as the cognitive abilities necessary to distinguish right from wrong, to understand the consequences of actions, and to make moral judgments are undermined by changes to the quantum mechanical basis of ethical reasoning. The implications extend beyond human society to encompass the entire biosphere of any world affected by FTL-induced quantum changes. Every living organism, from the simplest bacteria to the most complex mammals, depends on quantum mechanical processes for its survival. The cellular machinery that converts nutrients into energy, that repairs damage from environmental toxins, that allows organisms to reproduce and pass their genes to the next generation, all of these could be disrupted by changes to the fundamental constants that govern quantum mechanical interactions. Ecosystems that have remained stable for millions of years could begin to collapse as the quantum mechanical foundations of biochemistry shift beneath them. Food webs could unravel as organisms find themselves unable to digest their normal prey or unable to avoid being digested by their normal predators. Symbiotic relationships that have evolved over eons could break down as the quantum mechanical signals that coordinate cooperation between different species are disrupted. The timing of biological processes could become unreliable as the quantum mechanical clocks that organisms use to coordinate their activities with seasonal changes are affected by altered physical constants. Migratory animals might lose their way as the quantum mechanical compass systems they use for navigation begin to provide incorrect information. Pollinating insects could find themselves unable to locate flowers as the quantum mechanical signals they use to detect nectar and pollen are scrambled by changes to the vacuum state. Plant communities could collapse as photosynthesis becomes less efficient due to quantum mechanical changes affecting the molecular machinery that converts sunlight into chemical energy. The primary productivity that forms the base of most food webs could decline dramatically, leading to ecosystem collapse that spreads upward through the food chain until even the largest predators are affected. Marine ecosystems could be particularly vulnerable as the quantum mechanical processes that allow marine organisms to extract oxygen from water, to regulate their buoyancy, and to navigate through three-dimensional ocean environments are disrupted by FTL-induced changes. Coral reefs, rainforests, and other biodiversity hotspots could become barren wastelands as the complex web of interactions that sustain them unravels due to quantum mechanical disruption. The planetary implications extend beyond biology to encompass the geological and atmospheric processes that maintain the conditions necessary for life. The quantum mechanical forces that determine how atoms bond together in rock-forming minerals could be altered by FTL technology, potentially destabilizing the geological processes that have shaped planetary surfaces for billions of years. Volcanic activity could become unpredictable as the quantum mechanical properties of magma are altered by changes to the vacuum state. Earthquake patterns could shift as the quantum forces that determine how rocks fracture and slide past each other are modified by exotic matter effects. Even the magnetic field that protects planets from cosmic radiation could become unreliable as the quantum mechanical processes that generate it in planetary cores are disrupted. Atmospheric chemistry could be altered in ways that make planetary surfaces uninhabitable. The quantum mechanical reactions that maintain the balance of gases in planetary atmospheres could be disrupted, leading to runaway greenhouse effects or the loss of atmospheric components essential for life. Weather patterns that have remained stable for geological ages could become chaotic as the quantum mechanical processes that drive atmospheric circulation are affected by changes to fundamental physical constants. The implications cascade upward to affect entire star systems and galactic regions. The nuclear fusion processes that power stars depend on quantum mechanical tunneling effects that allow hydrogen nuclei to overcome their mutual electrical repulsion and fuse into helium. If these quantum mechanical processes are altered by FTL technology, stellar evolution could become unpredictable, with stars burning out prematurely or exploding in ways that differ from normal supernova. Planetary formation processes could be disrupted as the quantum mechanical forces that allow dust and gas to accrete into solid bodies are altered by changes to the vacuum state. Star systems that are currently stable could become chaotic as the gravitational interactions between planets are affected by quantum mechanical changes that alter the fundamental constants governing gravitational attraction. The interstellar medium itself could be affected as the quantum mechanical processes that determine how atoms and molecules behave in the near vacuum of space are disrupted by FTL-induced changes. The cosmic rays that carry energy and matter between star systems could be deflected or absorbed in unexpected ways, altering the radiation environment that affects planetary atmospheres and biological evolution. galactic structure could become unstable as the quantum mechanical properties of dark matter, whatever it might be, are altered by propagating changes to the vacuum state. The spiral arms that give galaxies their distinctive appearance could begin to dissolve as the gravitational forces that maintain them are affected by quantum mechanical disruption. The supermassive black holes that anchor galactic centers could become unstable, potentially leading to the disruption of entire galactic systems. The cosmological implications extend these effects to the largest scales imaginable. The expansion of the universe itself could be affected if the quantum mechanical processes that drive dark energy are altered by FTL technology. The cosmic microwave background radiation that carries information about the early universe could be distorted by quantum effects, making it impossible to understand cosmic history or predict cosmic evolution. The large-scale structure of the universe, the cosmic web of matter and energy that connects galaxy clusters across billions of light years, could begin to dissolve as the quantum mechanical foundations that maintain it are undermined by cascading changes to the vacuum state. The entire observable universe could transform into something utterly alien and unrecognizable as the quantum mechanical constants that have remained stable for nearly 14 billion years are altered by the pursuit of faster-than-light travel. The ultimate irony is profound and heartbreaking. In our quest to explore the universe, to connect with other forms of life and consciousness, to join a galactic community of intelligent beings, we could inadvertently destroy the very foundations that make exploration, connection, and consciousness possible. The technology meant to bring us closer to other worlds could ensure that no worlds remain capable of supporting the complex chemistry necessary for life and awareness. The universe appears to have constructed itself with remarkable wisdom, establishing barriers that protect the fundamental structures of existence from the unintended consequences of intelligence and ambition. The speed of light that seems to limit our cosmic dreams might actually be the guardian of those dreams, ensuring that consciousness has a stable foundation upon which to build its aspirations. As you rest in the gentle darkness surrounded by the invisible quantum processes that maintain the stability of atoms, molecules, and the neural networks that allow you to contemplate these cosmic mysteries, you are witnessing something more precious than all the distant galaxies combined. The delicate balance of forces that makes your thoughts possible, that allows your consciousness to emerge from the quantum dance of particles and fields, represents a cosmic achievement so improbable and so fragile that it deserves our deepest reverence and protection. The quantum vacuum that fills the space around you is not empty, but alive with the constant activity that maintains the existence of everything you know and love. Every virtual particle that winks into existence and disappears again, every quantum field fluctuation that maintains the stability of matter, every invisible process that keeps the fundamental constants of nature operating within the narrow ranges that allow for complexity and consciousness. All of these continue their ancient work in the darkness, protecting the miracle of your awareness from the chaos that would ensue if their delicate balance were disturbed. Perhaps the greatest journey we can undertake is not outward to distant stars, but inward to a deeper appreciation of the quantum mechanical foundations that make any journey meaningful. In understanding why faster-than-light travel would be so catastrophically dangerous, we gain insight into why the universe we inhabit is so remarkably, improbably, and preciously stable. The cosmic speed limit that appears to confine us might actually be the thing that preserves the very possibility of being confined at all, ensuring that consciousness has a coherent reality within which to dream of transcending its boundaries. In the end, the universe has given us something infinitely more valuable than access to the stars. It has given us the quantum mechanical stability that allows us to wonder about the stars in the first place. That gift, invisible and intangible though it may be, represents the most sophisticated technology ever encountered, more elegant than any machine we could build, more precise than any equation we could solve, more essential to our existence than any resource we could ever hope to discover among the distant worlds that beckon to us across the cosmic void. The gentle hum of quantum fields maintaining their perfect balance, the invisible symphony of forces preserving the integrity of atoms and molecules, the quantum mechanical processes that allow your neurons to fire and your thoughts to form. All continue their eternal dance in the darkness around you. It is a dance so fundamental that disrupting it would mean the end, not just of human consciousness, but of the possibility of consciousness emerging anywhere in the cosmos. And perhaps that understanding, that deep appreciation for the quantum foundations of existence, is worth more than all the worlds we might have visited, more precious than all the civilizations we might have encountered in our dreams, of faster-than-light travel. Sweet dreams, fellow guardian of quantum stability. May your rest be peaceful, and may you wake tomorrow with renewed wonder at the invisible forces that make wonder itself possible.